sklearnmetricsd2 pinball score. Description: the D2 pinball score is a metric that assesses the quality of probabilistic forecasts. Specifically, it measures the deviation of the predicted quantiles from the true values. The metric works by comparing the quantiles of the predicted distribution with the corresponding quantiles of the actual data. The metric is based on the idea that a good probabilistic forecast should produce quantiles that enclose the true values with a certain probability. Inputs: y true, the true values. It's a 1D array of the actual target values. Y pred, the predicted quantiles. It's a 2D array where each row represents a sample and each column represents a quantile level. Outputs: score, the D2 pinball score. It represents the average deviation of the predicted quantiles from the true values. A lower score indicates a better fit. Steps: for each quantile level, the metric calculates the difference between the predicted quantile and the true value. The differences are then squared and averaged across all quantiles and samples. Metrics: D2 pinball score measures the average deviation of the predicted quantiles from the true values. Visualization plots: quantile QQ plot visualizes the distribution of the predicted quantiles against a true quantiles. Time series plot visualizes the predicted quantiles alongside the actual values over time. This can be used to assess the performance of the model for different quantile levels. Fine-tune parameters: quantiles, a list of quantiles to calculate. Defaults to 0.1, 0.5, 0.9. Adjust these based on the desired level of confidence or the specific application. Uncertainty methods: quantile regression. Use quantile regression to explicitly model the quantiles of a distribution. Bayesian neural networks use Bayesian methods to estimate the uncertainty in the predictions. Challenges and fixes. Challenge 1: the metric can be sensitive to outliers. Sample use case that resulted in challenge 1: a single large outlier in the true values can significantly inflate the D2 pinball score, making it difficult to assess the model's overall performance. Fixes to challenge 1: robust estimation techniques use robust methods like trimmed mean or M estimators to calculate the score. Outlier detection and removal: identify and remove outliers from the true values before calculating the score. Challenge 2: the metric is not designed to handle time series data with autocorrelation. Sample use case that resulted in challenge 2: if the data exhibits strong temporal dependencies, the D2 pinball score may not accurately capture the performance of the model, as it assumes independence between samples. Fixes to challenge 2: use a time series specific metric or adjust the metric to account for autocorrelation. For example, consider using a rolling window or applying a time series decomposition to the data before computing the score.